Welcome to the first video for the Algebra Final Review for Standard 5. We're going to go a little bit away from the review guide for a moment so we can just go over some of these representations. If you don't want to do that, I suggest you do, but if you don't want to do that, you may go ahead and go on to the second video, and it should be more in line with the review guide. In this one, I just want to talk about multiple representations of linear functions. That is when back in chapter 4, we had something that looked kind of like this, and we talked about going between all of these different representations, how to go from a rule to a graph, or a graph to a pattern, or just any direction on this. Today I'm going to focus in this video on going to the rule, going from a graph to a rule, pattern to a rule, table to a rule. Remember that I've got some examples of them here. Okay, so there are three big ideas to think about. Those are a changing part and a part that kind of starts or stays the same. Okay, so here they are. What part stays the same, or how does it start? We use some other terms for that. Sometimes we'll call it B, the starting point, the y-intercept, initial value. Okay, and 2, how does it change? Is it going up by 5? Is it going down by 3? Is there a certain amount being added each time? We use other terms for that sometimes. We call them M, growth rate, or slope, or some of the terms we've used for that. And then how do we visualize it? Particularly with patterns or graphs, sometimes we can see these two ideas in the visualization, and that becomes important. Okay? So here's a little table, very similar to the one we made a long time ago, but it basically shows where these two values in our standard form, or our slope-intercept form, y equals mx plus b, come from. If I'm looking at a table, the m is the constant amount of change for 1 unit of x. Remember that if it's linear or a straight line, that it'll always change by the same amount per unit of x. Okay, the b is going to be the value of y when x is 0. Okay, so we'll find x when x is 0. We'll look at the y for that. Okay, if we're looking at a graph, we're going to look at the slope triangle and find the rise over the run for the m, and we're going to find the y-intercept for, or where it crosses the line crosses the y-axis for our b value. If we're going from a pattern or situation, the growth rate, how many tiles are being added each time, how much is it changing by each time, is the m, and the amount we start with, or the amount of tiles in figure 0, becomes the b. One of my favorite examples is if the cell phone company charges you $30 a month and 10 cents a minute, which one is which? Well, that $30 is an amount that kind of stays the same. So it becomes the B, or the starting initial kind of a value. But that 10 cents a minute changes. It changes the amount of our bill, and usually the growth amount is going to be the M. Okay, now let's look at going from a table to a rule. Okay, we need to be able to find the growth rate and the starting point. So let's go ahead and do that. We said that the starting point would be the y value when x equals 0. So let's see, where does x equal 0? X equals 0 right here. So then I look over at its y value, and its y value is -3. So I'm just going to put that right there. Make sure you've got a good idea of where that came from. And now I need to find the growth rate. Now I, on purpose, in this table, did some things to kind of force us to look at how we think about growth rate. Okay? The growth rate here, x went up by 2, and the y went up by, let's see, I believe that's 8. Went up by 8. Here, it went up by 1, and it went up by 4. Here, it went up by 1, once again up by 4. Here it went up by 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, and it went up by 16. Now, if I want to find the unit rate, how much it goes up for 1x. Here it went up for 2x's, and it went up 8. Well, if it's going up 2, then I want to find half of that. Okay, and so if I put 8 over 2, that's the change in the y over the change in the x, I get a change of 4. Let's see if that's true in the other ones. Here, those two go together. That was 4 over 1, which is 4. Once again, the same one, so I'm not going to do that one. Then we have one that went up 16 for every 4 x's. So it went up 16 for every 4 x's, and that is 4. That's the unit rate that we're talking about. So it's going up 4 each time. So the rate here is 4x minus 3. I could check this by plugging values in. I'm just going to pick one right here, 2. 4 times 2 is 8. Minus 5 should equal the y, which is 5. So it is. 4 times 6 is 24. Minus 3 is 21. So we've written a rule for that, and the rule is y equals 4x minus 3. Okay, next one we have a graph. I'm not even sure you're going to be able to see it, but I'm going to bring it up a little bit so we can look. Two things we look for in a graph. We look for where it crosses the y-axis, and it crosses right there. And if I count these numbers, it's crossing at -3. Now I need to make a slope triangle, and I know that you might not be able to see this, but basically, to get to the next line, next place on the line, I go over 1, I go up 4. So the rise over run is going to be 4 over 1. If I'd gone if I'd gone over 2 or 3, then I would basically still make my fraction, but I'd try to reduce it. For example, this could have been 4 over 1. It could have ended up being 8 over 2, because that's also 4. Okay, so let's go ahead and put those values in. Let's see, the rate of change is the slope triangle, rise over run. 4 over 1, I'm just going to write that as 4. And it crossed the y-axis at -3. So I'm going to put that in as y equals 4x minus 3. Okay, now this actually goes a little bit with the next section, but we're going to do it, just a little bit of review on it here in the few moments of this video. We're going to write a rule from this pattern. When I'm writing a rule from a pattern, I'm looking at the starting value. How many tiles are in figure 0? Well, there's 1 tile in figure 0, so that's pretty lucky for us. So we're just going to put this down as plus 1. Now I want to look and see how much it's growing and how. Okay, so if I look at this, it looks like this piece right here is probably this one. So let's see if that makes sense. I'd add those there, and let's see what that does. I'm going to color them so you can see. So these are the ones we added when we went from figure 0 to figure 1. Okay, then these are the ones we added when we went from figure 1 to figure 2. And I'm seeing a pattern here, figure 2 to 3. And I can see really nice now. I can use some numbers also to help me. So I'm going to do that really quick. Okay, there's 1 tile. There's 3 tiles, there's 5 tiles, 7, and 9 tiles. So I can see that I'm adding 2 tiles visually. I can also see that I'm adding 2 tiles by looking at the number of tile numbers. So that's its growth. Its growth is going up by 2 each time. So my rate of change is going to be 2x. We also want to look at how the growth relates to the figure number. Okay, figure 0 didn't have any growth. Figure 1 had 2. Figure 2 had, let's see, figure 2 added, so let's look at this. So I'm thinking this way. Figure 1 had 1 each there. Figure 2 had 2 each there. Figure 3 had 3 each in each arm. Figure 4 had 4 each. So I could come over here and give an idea of what figure 100 would look like. It would probably have 1, and then it would have 2 arms over here. One arm like this would have 100 tiles in it, and one arm this way would have 100 tiles in it. So that's where we see the growth.